Welcome back to Smith Coding and Design. This is tutorial 3 on our Z-axis stepper motor mount. So last time we left off with doing or finishing the counter bores for our M3 screws. Today we're going to finish up Op1 by finishing the large chamfer here in the center and then going ahead and doing our drilling operations. So with that being said, let us go ahead and begin. I am going to go to 3D contour, and I'm going to go into my Tormach 770 library here, and I am going to choose my Gorilla Tools 3/8 inch ball nose end mill. We are at 7,500 RPM, 30 inches per minute. I'm going to go into geometry, and for the machining boundary, I'm going to click selection. I'm going to click the upper part of our chamfer, the upper contour or the circle around the top of our chamfer. And then I also want to say avoid surfaces, and I want to select the bottom here. We've already finished the bottom and our sidewalls, so we want to make sure that we don't touch them. We shouldn't touch the sidewalls, but if we do not select the floor here of the pocket, we will indeed touch that, so we want to make sure we don't. Okay, so that's good. We'll then go to our heights. Again, we've removed all the material off the top of our part, so we want to use the modeled top. Okay, and the next thing that we want to do is come over here into passes, and all I'm going to do here is change the maximum step down to 20 thousandths. And then I'm going to enable smoothing and feed optimization. And that should be everything for this toolpath. We will go ahead and click OK. I'm just going to browse here and make sure there's nothing I forgot. That looks good. We'll click OK. And then we'll go ahead and simulate. And again, we just want to make sure that while we are making this chamfer, that we are not touching the sidewall or the floor. So I'm going to go ahead, right click and simulate. And then again, I'm just going to drag through the timeline here. There we go. We're just following the contour of our chamfer and then walking our way all the way around, finishing up. It's going to look nice, smooth, and beautiful, and you will see that as we finish the toolpath on the Tormach at the end of the tutorial. Alright guys, so that's it for our first toolpath. So what we're going to do now is go ahead and get into our drilling operations. So with that being said, what we want to do is spot drill our center hole. This is going to be a large 1/4 inch hole, so we'll just use a 1/4 inch carbide drill after we spot it. However, for our smaller M3 holes, we're not going to be able to get a spot drill in there, so we're just going to use a 3.3 millimeter carbide drill to go and make the holes again for M3 mounting screws. So let's go ahead and begin. I'm going to go to drilling. Let's go back to our home view, and then what I'm going to do is go to my tool library, and I'm going to select a spot drill. I have a 1/4 and a 3/8 140 degree spot drill. I'm going to use the 3/8. Select OK. We are at 4,000 RPM, and we're just going to plunge at 13 inches per minute. And what we're going to do is wrap it in and retract. So we'll go ahead and do that now. We'll go to geometry, and then we will select the hole, of course. Now, what we always want to be careful with spot drilling is that we never want to go to the whole bottom, because we will be essentially trying to drill our spot drill all the way through our part, which will most likely break our drill or damage our machine or just ruin our part. So what I'm going to do is go to hole top, and then I am going to go minus 25 thousandths, so I'm going to go 25 thousandths below the hole top. There we go. And that should do it for us. So we were just using a drilling with a rapid out. So it's a very, very quick operation. So we'll go ahead and simulate. And again, all we're doing is making a nice spot for our 1/4" drill. There we go. So nothing to write home about there. We will go in and chamfer everything at the end, so that's fine. We don't need to worry about we don't have to worry about trying to chamfer the hole in the center with our spot drill. Again, we're going to do that with a chamfer mill at the end. So now what we need to do is go ahead and go to another drilling operation. We'll go back to our home view, and this time we are going to select our 1/4" carbide drill. So again, I'm going to go to my Tormach library. We're going to be using a Kennametal Go drill, and I want the 1/4". Select OK. 4,000 RPM, 15 inches per minute. We'll go to geometry again, center hole here. And for our heights, this time we do want hole bottom. I'm going to check drill tip through the bottom, and then I'm going to go an extra 50 thousandths just to make sure that we do indeed drill our tip all the way through the bottom of the hole, especially because we want to use this known geometry to probe and indicate our part for Op2. All right, so that all looks good. What I'm going to do now is go ahead and select deep drilling with full retract, and I'm going to make the pecking depth 30 thousandths. So that's all good. I'm going to click OK. And then what we'll do is we'll go ahead and simulate. And again, we'll just press play here this time since it's going to be rather quick. Again, we're just going to peck our way all the way through the bottom of the part. And I notice I made a mistake. Remember, I said we wanted to actually probe the hole to indicate our part in for Op2. Well, I chose hole bottom as the bottom height when I actually want to go all the way through the stock. So I'm just going to right click and edit. And this is why you simulate, because it's very easy to make a costly mistake. So let's go ahead and instead of our bottom height being hole bottom, we want it to be the stock bottom. That way we're drilling all the way through the part and through the stock. That way, again, we can probe for Op2. So there we go. So what I'll do now, we'll just go to the right view here, and you can see the drill is going all the way through. But just to be sure that, I'm going to go to simulate again, and I'm just going to drag toward the end. Come on, there we go. So you see that our drill tip does indeed go all the way through the part and through the stock at the bottom. So I am happy with that. So now to finish off our drilling operations, we need to make the holes for our M3 screws. So what I'm going to do is just go ahead, go back to the home view, go to drilling again, go to my tool library, and this time I'm going to go with a Kennametal drill that's 3.3 millimeters in diameter. So that should give us 0.3 millimeters of clearance for our M3 screws. So let's go ahead and select it. And what we can do this time to make our life easier is we can use the same diameter to get all 4 holes at once. We'll do that in a second. Our spindle speed is 4,000 RPM, again at 15 inches per minute. So here we go. I'm just going to go ahead and select one of the holes, and then I'm going to say select same diameter, and there we go. We saved ourselves time, and Fusion found all of the holes for us. There's only 4 holes here, but if you had 100 holes, it would obviously save you time rather than clicking each hole. All right, and so this time, let me go back to home view just to make it a little easier here. We'll zoom in just a little bit. We do want hole bottom, and again, I'm just going to drill the tip through the bottom, and we are going to go 50 thousandths past the bottom of our part, again, just to make sure we do indeed make our way all the way through the part. That way we can chamfer the holes on the back side. All right, again, I'm going to go to deep drilling with full retract and make the pecking depth 30 thousandths. Click OK. And there we go, guys. Now we have all of our drilling operations finished. I'm going to go ahead and simulate. Again, this will be rather quick. We can see the simulation there. All we're doing is, again, just pecking our way through each of those holes and making sure that we do indeed go through the bottom of our part. Again, this time we don't need to go all the way through the stock, just through the bottom of our part. So we'll speed it up a little bit here. And there you go. Again, no collisions or anything of that nature. So we're good to go. And so now what we'll do is we'll go ahead and finish up Op1 by chamfering everything. So let's go ahead and do that. I'm going to go ahead and select 2D chamfer. So we're just going to go to 2D chamfer, as I've said many times. Sorry for repeating myself. And then we are going to go to our tool library. And I'm going to use a 1/4 Gorilla Tool Lemur chamfer. Select OK. 4,000 RPM, 20 inches a minute. You can go faster if you so choose. Then going to go to geometry. So we're going to want to get the outside. We're going to want to get the top of our counter bores. We're going to want to get the hole in the center here. And then we're going to want to go ahead and get the outside edges there, at least as close as we can get to the sidewall, just to make sure we knock down any burrs and make sure the part is not sharp such that we do not cut ourselves when we pick it up. All right, so that's good for geometry. So now we'll go to heights. Again, we've already removed all the material off the top of the part, so I want to use model top instead of stock top. We'll go to our passes tab, and I want a 15 thousandths chamfer. Okay. And then I'm going to go ahead and make my chamfer tip offset right at around 60 thousandths. Go ahead and do smoothing and feed optimization. And I'm going to change my lead-in sweep angle to 45 degrees, and that should be it. Let's go ahead and generate the toolpath. And then we will simulate. And that'll be it for this tutorial. We'll actually see the toolpaths performed on the Tormach, and then we'll go into Op2 in the next tutorial, and hopefully we'll be able to finish Op2 in one tutorial. We shall see how it goes. But anyway, let's go ahead, slow this down just a hair, and watch the simulation. So again, we're just walking around the outside here, giving a nice 15 thousandths chamfer. And then we're transitioning into the counter bores. And what we want to do here is, again, just make sure we're chamfering everything and that we didn't forget an edge, or that we don't run into any sort of collisions. So there we go. You could change, if we zoom in here, that's probably fine. You could try changing the chamfer clearance to see if you could get closer to those walls, but I think that that is fine. So everything there looks good to me, so I'm going to exit the simulation. And again, that's it for Op1. Now we're transitioning into the machining on the Tormach. Thanks again for tuning in. Please like and subscribe. All right, so we jump right into our 3D contour with a 3/8 inch Gorilla ball nose end mill, 30 inches per minute with a 20,000 step down. We're going in a nice smooth circular motion so that we get a good surface finish on this large chamfer. And so that does it for our 3D contour. We'll now go ahead and start transitioning into our spot drilling operation. The spot drilling operation goes fast, but we're going down 13 inches per minute and 25 thousandths below the top of our hole. And now we transition into our deep drilling cycle with a 1/4 inch Kinemetal Go drill, 15 inches per minute with a 30 thousandths pecking depth. And again, we're going all the way through the bottom of the stock such that we have a hole to probe for Op2. And so now we'll go ahead and begin transitioning into our next deep drilling cycle. And so here we do a deep drilling cycle with a 3.3 millimeter Kinemetal Go drill. We're going 15 inches per minute with a 30 thousandths peck. Again, we're just going around the 4 corners and making the holes for our M3 socket cap screws such that we can attach the mount to the top of a stepper motor. I use flood coolant on all the drilling operations for superior chip evacuations. And so now what we'll do is we'll go ahead and start transitioning into the 2D chamfer. And again, we will use flood cooling on that 2D chamfer. All right, here's the chamfering operation. We're using a 1/4 inch Gorilla chamfer, 20 inches per minute, and we are giving the edges a 15 thousandths chamfer width. Again, I left the flood coolant on here, so it's slightly hard to see, but that finishes up the part. I hope you enjoyed. Please like and subscribe, and I'll see you in the final tutorial where we finish our motor mount.